Hi everybody, today let's talk about commutative law in combined transformations. Actually, in Form 1 you learn about commutative law, still remember? Okay, two of the example of commutative law is additions and multiplication. For example, if I ask you to calculate this one, 6 plus 29 plus 4. So we can actually rearrange all this term to help us to get the answer in an easier way. So we can write 6 plus 4 first, then followed by plus 29. If we calculate this way, it will be easier. 6 plus 4 will give you 10. 10 plus 29 will give you 39. So we are actually applying commutative law here. So another example is multiplication. For example, if I ask you to calculate 4 times 29 times 25. If you want to calculate mentally like this, 4 times 29 then times 25, it will be a little bit hard. But we can actually apply commutative law to help us to get the answer easily. So how about I rearrange all this term first. 4 times 25 times 29. Why do I want to do so? Because 4 times 25 will give you 100. 100 times 29 will give you 2900. So these are the few examples of commutative law. But today we are not talking about this one, commutative law for calculations. We are talking about commutative law in combined transformation. So how do we know that a given combined transformation satisfies commutative law or does not satisfy commutative law? If the final image of an object under the combined transformation PQ and QP are the same, image produced from PQ and image produced from QP are the same, then we say PQ satisfies the commutative law. If PQ and QP produce different images, then we say PQ does not satisfy commutative law. Let's look at some example. The diagram below shows a quadrilateral A drawn on a Cartesian plane. So here we have few transformations. A is a translation 3, 2. B is a refraction on the line, y equal to 5, and C is a rotation of 180 degrees at center 6, 5. So we want to determine whether each of the following combined transformation satisfies the commutative law. Okay, let's look at part A first. We want to determine whether this combined transformation AB satisfies commutative law or does not satisfy commutative law. So how do we know? We need to draw the image for this combined transformation AB and the image for the combined transformation BA. If both of them produce the same image, images, then we say this combined transformation AB satisfies commutative law. Now, let's look at AB first. This one need to be more careful. AB, B is the first transformation, and A is the second transformation. Okay, so what is B? B is refraction on the line y equal to 5. So first, we need to draw the axis of refraction. Y is equal to 5, which is over here. So this is the axis of refraction. Y equal to 5. If this object is refracted on this line, so the image will be here. This point will become here. So how do I get the position here? From here you calculate until you touch the axis of refraction. For example, 1, remember the number, then recalculate again 1. This is the image of this vertex. So how about the image of this vertex? 1, 2, remember the number 2, then recalculate again 1, 2 over here. How about this one? 1, 2, 3, remember the 3, then recalculate again 1, 2, 3. So here do the same thing, 1, 1. Okay, So this is the image of object A under this transformation B. Let me connect all these points together first. Okay, so now we are going to draw the image for the transformation A. So A is a translation 3, 2. 3, 2 means that 3 units to your right. 2 means that 2 units go up. Okay, let me determine the image for this vertex first. 1, 2, 3. Go up 2 units, 1, 2, which is over here. So you can calculate again from here. 1, 2, 3, 1, 2. If you don't want to do so, you can do it another way. For example, now from here go here 2 unit, right? So do the same thing. 1, 2. From here go down 1 unit, go down 1 unit. How about here? Go down 1 unit, then go to your right 1 unit. We can do the same thing over here. Go down 1 unit, go to your right hand side 1 unit. Okay. Next thing, just connect all these points together. Okay, so this is the final image of object A under this combined transformation A, B. So now we are going to draw the image for this combined transformation BA. So BA means that A is the first transformation, then followed by B. B is the second transformation. A is a translation 3, 2. 1, 2, 3. Go up 1, 2. Okay, here 1, 2, 3. Go up 2 units 1, 2. So you can start calculate from here or from here. 1, 2, 1, 2. From here go up 1 unit. Here do the same thing, go up 1 unit. Okay, so next thing, connect all these vertices together. Okay, so this is the image of object A under this transformation A. Next thing, we want to draw the image for this second transformation, which is a refraction. So we need the axis of refraction, which is y equal to 5. Okay, so this is the axis of refraction, y equal to 5. I'm going to draw the image for this vertex first. 1, 2, 3. Remember the number 3? Then calculate again. 1, 2, 3. This point is the image of this point. Okay, do the same thing for this one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. Okay. Now, let me connect all these points together. This is a final image. This is the final image of object A under this combined transformation BA. You will notice that these two combined transformations produce different images. One of the images over here, another image is over here. So we can make a conclusion that AB, the combined transformation AB, the combined transformation AB does not satisfy commutative law. Okay, now let's go to part B. Okay, so this time we are talking about BC. So we want to know whether this transformation, this combined transformation BC, satisfies the commutative law or does not satisfy the commutative law. How do we know? we need to draw the image for the combined transformation BC and the combined transformation CB. If both of them produce the same images, then we can make a conclusion that this combined transformation satisfies commutative law. If they produce different images, then we can make a conclusion that this combined transformation does not satisfy commutative law. Now, let's look at BC first. Again, C is the first transformation, remember. And this is the second transformation. So this time involve rotation. You have to be more careful because personally I feel that among the few transformations that you have learned, translation, refraction, rotation, and enlargement, rotation is the hardest one. So you need to be more careful when you deal with the rotation. Okay, so we need to draw the center of rotation first, which is 6, 5. 6, 5 is over here. Okay, so this is the center of rotation. Let me label it first. So here, I'm going to use L shape to help me to determine the image of this object under this transformation C. 180 degree. You will notice that the question does not tell you clockwise or anti-clockwise because here is 180 degree. If you go clockwise or you go anti-clockwise, both of them are actually the same. Okay, let me use L shape to help me to get the image. 1, 1. Okay. Now I'm going to draw the image for this vertex. If I rotate it 180 degree, 1, 1, 1. Okay, let me draw it. 1, 1. Again, 1, 1. From here, go here is 90 degree. From here, go here is another 90 degree. Total is 180 degree. So we know that the image for this vertex is over here. Let me use red color. Okay, so the rest repeat the same thing. One, two, three, 1. 3, 1. Remember? 1, 2, 3, 1. This is 90 degree, but we are looking for 180 degree. I need to rotate it some more 90 degree. 3, 1. So do the same thing here. 1, 2, 3, 1. Okay. The image for this vertex is over here. Repeat the same thing for the rest of the point. Now I am going to find the image for this vertex. Always remember, start counting from the center of rotation, from this center. 1, 2, 3. 1, 2, 3, 2. 1, 2, 3. 1, 2, 90 degree. We need another 90 degree. 3, 2. Remember, 1, 2, 3. 1, 2. Okay. This is the image of this vertex. Do the same thing for the last point. 1, 2, 1, 2. Sorry, should be 3. 1, 2, 3. So do 3. 1, 2, 1, 2, 3. Do the same thing here. 1, 2, 1, 2, 3. Okay. So this point is the image for this vertex. Next thing, we just connect all these points together. Okay. So if you worry that you will confuse, you can actually label it. For example, you can label it B, C, D, E. This is for your own reference. So when you determine the image, you can label it B prime, C prime, D prime, E prime. So it's up to you, you want to label it or not. If you feel that if label it will help you to get the answer easier, so you can go ahead and label it. Okay, so next transformation is B. B is a refraction on the line y equal to 5. This is a refraction, so definitely I need to draw the axis of refraction first, which is y equal to 5. Now I'm going to refract this image, go up here. 1, 1, 1, 2, correct, 1, 2. Okay, let me draw this line, make it should be very straight, perpendicular, uh, parallel to the y-axis. Okay, 1, 2, 1, 2. Okay, do the same thing here. 1, 1, 1, 2, 3. Remember the number 3. 1, 2, 3. Okay. So this is the image. This is the final image. Final image. Okay. Final image. This is the final image of this combined transformation BC. Okay, now let's go to CB. Again, when you see CB, B is the first transformation and the C is the second transformation. Okay, now B is a refraction. I think this time it should be no problem, right? We have done a lot of refraction over here. 1, 1, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, 1. Okay, so if you are still not really sure about this, how do we get the image for translation, refraction, rotation, and enlargement, you can watch my previous video. Okay, let me connect all these points together first. Okay, I should draw it more accurate over here. Yeah, okay. So this is an image of object A under this transformation B, refraction. Now I'm going to rotate it 180 degrees at the center 6, 5. Same thing, I need to draw the center first. Okay, so just now I told you that if you want to label the vertex, you can go ahead. So for example, you worry that you will get confused, you can actually label the vertex. For example, B, C, D, E. It's totally up to you. You don't want to label it, it's okay, as long as you can get the final image correctly. Okay, let me get the image for this vertex B first. Remember, start counting from the center. 1, okay, let me use another color. 1, 2, sorry, not 1, 2, 1, 1. Rotate it 90 degrees, 1, 1. Again, because we want 180 degrees. 1, 1. Okay, so this is B prime. This is the image for this vertex. Okay, I just erase this one first so that you don't get confused. Okay, now let's go to point C. 1, 2, 3, 1, 3, 1, 1, 2, 3, 1. Again, 1, 2, 3, 1. This is C prime. 90 degree, 90 degree, total up is 180 degree. Oh, it's over here, correct? 3, 1, 3, 1, okay, correct. Okay, do the same thing for the rest of the point. D. 1, 2, 3, 1, 2, 3, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Okay, so this is point D prime. We have one more point to go, which is point D. 1, 1, 2, 3, 1, 2, 3, 4, 3, 4, 1, 2, 3, 1, 2, 3, 4, 90 degree. Another 90 degree, 1, 2, 3, 1, 2, 3, 4. Oh, hold on, let me check. Oh, sorry student, I make a mistake here. Do you notice what is a mistake that I just done? I start from the wrong point. The center is over here. I should start counting from the center here. It's not B. Okay, let me redo it again. Start from the center, remember. So the other point should be correct. Okay, let me calculate again for this last point. 1, 2, 1, 2, 3, 2, 3, 1, 1, 2, 1, 2, 3. Again, 1, 2, 1, 2, 3. Okay, which is over here, D prime. Let me connect all these points together. See whether these both transformations produce the same images or not the same. If they produce the same images, then we can make a conclusion that this BC satisfies commutative law. Connect all these points together. Okay, so this is the final image. Let me compare these two images. 7, 6, 7, 6. Okay, this point same. All the points are the same. You will notice that these two final images produced from BC and CB, they are exactly the same. From here, we can make a conclusion that the combined transformation BC satisfies the commutative law. Okay, the combined transformation BC satisfies the commutative law. Okay, so that's all for this commutative law in combined transformations. Hopefully you understand about this commutative law in combined transformation. See you next time. Bye bye.